Hey guys, we're back for Tuesday on our DMR number 30. We're going to start with number 1 today. Number 1 is our fraction problem. It says Mom made a cake for my birthday. Joe ate 1/4 of the cake and Sue ate 1/3 of the cake. How much of the cake is remaining? So this is just like Mondays where we're going to combine how much of the cake was eaten and then we're going to look at what was left over after we do that. Okay? I'm trying to think if I can do this in a picture form. I know I can, but I'm going to do the math first and see if I can follow up with a picture. So I'm going to add Joe and Sue, and that'll give me a total of what was eaten from the cake, and then I can look at what was remaining after that. So I need to find a common denominator or a least common multiple between 4 and 3. So 4, 8, 12, 3, 6, 9, 12. Common denominator is 12. So some number times 4 equals 12. Some number times 3 equals 12. And then I've got my new fractions set up on this side. So 4 times 1, 2, 3 is 3 twelfths. 1/4 is equal to 3 twelfths. 1/3 times 3 times 4 is 12. 1 times 4 is 4. 1/3 is equal to 4 twelfths. So now we can combine them. So between Joe and Sue, they ate 7 twelfths of the cake. Don't mind my kitty. So they ate 7 twelfths of the cake. Now, going back to the problem, it says how much was remaining. So we need to take the whole cake, and we could draw a picture here if you want. Divide it into twelfths. Let's make sure I do this right. 1, 2, 3, 4, 5, 6. I'll cut it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. So I'm going to shade in 7 twelfths. They ate 1, 2, 3, 4, 5, 6, 7 of the 12 pieces. How many are left? Let's count. 1, 2, 3, 4, 5. So 5 twelfths is left. Hope you can see that visually. So we would say 5 twelfths of the cake is remaining. Awesome job. All right, let's look at number 2. Number 2 is a rounding problem, following that same pattern that we did for Monday. It's except for this time we're going to round to the whole number. So 893 and 682 thousandths. All right. Now, this problem was so tricky for us when we were in school because when we were looking at the whole number, some people were looking at the hundreds place, some people were looking at the tens, some people were looking at the ones. So we need to find common ground of like what is the whole number. If we're being very technical, this is the whole number. The decimal separates the whole from parts. Think about like money. The decimal point separates your dollars from your change. So the reason why I circled or boxed in the whole number is because 893 is either going to stay 893 or it's going to change to 894. Those are your only two choices. Not 800 and not 900. You need to think about the whole number as a whole. Okay? So, I'm going to show you on a number line what I mean. I think the number line is really helpful for me. Okay? And right here in the middle, we would have $893.50. Our number, I'm going to just round, is $893 and about 68 cents. So I would say maybe here would be $893.68. Okay? Do you agree? Having 68 cents is a little more than 50. So, looking at the number line, am I closer to $894 or am I closer to $893? If you said we're closer to $894, then you are correct. And that's how you round based on the whole number. You have to look at the entire thing. Okay? Awesome. All right. Which decimal is equivalent to 4/25? Huh. Okay. So I'm going to let you use a calculator on this one to kind of teach you some middle school tricks if they let you use a calculator. And then we can do it out for the division on paper. So if you want to use a calculator, you're going to type in the numerator divided by the denominator. So you're going to type in 4 divided by 25. Hit enter. You should get 16/100ths, which matches answer choice C. Let me show you how you can do it by hand. I like the calculator, and I think in today's world, we all have calculators. So it's important to use them to be efficient, but it's also important to understand what is happening when you use the calculator. So I know 4/25 is less than a half, and I know it's a decimal. So if I had answer choices that were whole numbers, I would cross those out. And if I had answer choices that were greater than 50 cents or 1/2, I would cross that out. Okay, see how I'm using number sense. Now you can set up 4 divided by 25. Now you can write 4 as 4.00, like $4 and no change. This allows you to put your decimal point in your answer because you know your answer is going to be less than one whole, so you're going to have a decimal as an answer. And then you can divide. 25 can't go into 4, but it can go into 40. How many times? One time. If I did 2 times, it would be 50, so that wouldn't be enough. So then you do 40, take away 25, which is 15. Bring down the 0. How many times can 25 go into 150? You would do 25, and I know it should be 6. Okay, and you can use your calculator for the multiples if you need it. Like, what is 25 times 6? Oh, yeah. And then you can find it. So that's how, this is what the calculator is doing for you when you type it in. But you may have a teacher next year that says, hey, I want you to divide your fractions out. And that's okay. You can say, oh yeah, Miss Conley taught me how to do that. All right, number 4. Number 4 is our word problem. It says, our school wants to go on a field trip to the park. There are 1,328 students at the school. We can fit 11 students on a small bus. In order for all of the students to get to go on the trip, how many buses will we need to get? So what we're going to do is we're going to take the 1,328 students. I'm not right so far over. And we are going to divide them 11 per bus. And this should let us know how many buses we will need. I am going to do this out by hand. If you divide it on the calculator, 1,328 divided by 11, you're going to get a whole number and then a remainder. We'll talk about that in a minute. You're going to get a whole number and a decimal, which signals a remainder. So 11 cannot go into 1. 11 can go into 13 one time. 13 minus 11 is 2. Bring down the 2. 11 can go into 22 2 times. bring down the 8. 11 cannot go into 8. But here's what you need to do. You need to put a 0 up here for no, it cannot. And then this is your leftover. Children, students, leftover. Okay, so it's not 12. Don't forget to put that 0 there. Because if you took 12 buses with 11 students in each, that would be only 132 students. And that doesn't make sense. Because you have 1,328 students you need to take. So I can assume also that 13 buses definitely would not be enough. So here is my question for you. You take 120 buses. It takes most of the students in your grade level, except 8 children are left. What do you do? If Ms. Conley's planning a field trip and I can take 120 buses, but 8 of my students who paid are left on the sidewalk, then I have messed up. That means that Ms. Conley needs to call someone and say, hey, we need another bus because we can't leave these 8 students behind. So what we really need in order for everyone to go, and it said in the problem, all of my students get to go, we really need 121 buses. So this is one of those interpreting the remainder problems where on Monday with the chairs in the rows, we just kind of dismissed the leftover chairs. We didn't really do anything with them. Whereas this problem, you definitely need another bus in order for everyone to go. All right, number 5. I'm going to zoom in a little bit on number 5 because it has those boxes. So it says Alex had 8 cases of water. His friends drank a half of each case. How many cases of water did his friend drink? And I forgot to show you the math on Mondays, so I'm going to show you the math behind this first so I don't forget. So let's say you have 8 cases and you drink a half of each. What's half of 8? You probably already know it's 4, but here's what I'm going to do, just so you see me multiplying. 8 full cases, 8 whole cases, so 8 times 1 is 8, 1 times 2 is 2. Remember, a fraction bar does mean division, so what's 8 divided by 2? 8 divided by 2 is 4. Let me show you how this works. So if his friends come and they drink a half of each case, you can show that visually, but then I need your answer in a whole number form. Okay, so what I'm going to do is I'm going to take this half of a case, combine it here so that I can see that's 1 whole case gone. I'm going to take this half and move it over. As long as your fractional pieces are the same size, which obviously they are, based on the picture, you can move them around. I think some students get like nervous to combine things, but as long as the pieces are the same size, you can combine them to make wholes. So based on the cases, I have 1, 2, 3, 4 whole cases. And that's where the math came from. Okay, awesome. Love you guys. Have fun. Enjoy your Tuesday.